In this video lesson, we'll be looking at a geometric series. What makes a sequence different from a series is that a sequence is a list and a series is a sum. Both of them will have a common ratio or a common factor. The formulas below we'll use in order to solve or find a geometric series. R cannot equal 1 because if it equals 1, our denominator will be divided by 0, and division by 0 is undefined. First example A, we'll look at finding the sum of n terms in a geometric series. The geometric series will follow this particular pattern. What we will need is we will use the first formula up above because I know the first term, A1, is 2. I know the common ratio or factor is 4 divided by 2, 8 divided by 4, so the common ratio is 2. And I know n because n is indicated by a sub n, which is the 15th term, so n equals 15. So plugging it into the formula, the sum of the first 15 terms of this geometric series will be 2 times 1 minus 2 to the 15th power divided by 1 minus 15. Again, order of operations and simplify. 4,681 would be the sum of the first 15 terms in this particular series. In example 2, slightly different example, here we know what the last term is and the first term, and we have the common ratio. So the second formula would suit our needs a lot better. So to find the sum, we'll take 4 minus 324 times negative 3, and again we'll divide it by 1 minus negative 3. Order of operations, the sum of those terms from 4 to 324 being the last term, that sum with the pattern of r equals negative 3 would be 244. In the next example, we're going to find the first term. So we have a couple of different scenarios here. In the first scenario, we're given s to the n, a to the n, and r. So this formula would suit us to solving for the first term. So let's plug in what we know. And we'll divide that by 1 minus 4. Again, some order of operations. And then we'll solve for A. I'll multiply both sides of the equation by negative 3 to eliminate my denominator, and A1 is fairly simple to solve from here. So that's negative 3,069, and if you add 3,072 to both sides of the equation, the first term is 3 in that particular series. Second type of example, here we have the sum of the first 8 terms is 39,360 with a common ratio of 3. So the formula that would suit us better here would be the formula where we have s to the n, r, and we know n because n comes from s sub 8. So we do have the value of n. It's 8. Again, let's just plug in what we know and the nice simple algebra equation to solve after that. Okay, simplifying. I'm going to take 1 minus 3 to the 8th power. Find that value, which is negative 6,560 divided by negative 2. If I divide these two numbers, I will get a factor for A1. which is 3,280 times A1, and that's equal to 39,360. Divide both sides of the equation by 3,280, and you will be able to solve for the first term, which is 12. Hope you found this video useful.